Hi. The next section that we are learning is just a subsection of still that 4.2, the basic structure of the atom. And we're going to be learning about what holds an atom together. What are the forces that hold an atom together? And the first force that we're going to look at is something that is called the electrostatic force. It's also sometimes called a Coulombic force or a Coulombic force of attraction. And you've heard of this before. It's the idea that particles with opposite charges attract each other and particles with the same charges repel each other. Okay, so the force of attraction between two oppositely charged particles, or the force of repulsion between two particles with the same charge. Okay, so you may have heard this as opposites attract. That's basically what the Coulombic force is boiled down to its simplest form. And so think about an atom. What are particles with opposite charges in an atom? Well, we know the proton in the nucleus and the electrons in the electron cloud have opposite charges. And so that's what you see here on the right-hand side. Okay, on the right-hand side of this, you can see that we are, right, the nuclei that between those two atoms and within an atom itself, the nucleus is attracted to the electrons and the electrons are attracted to the nucleus. This is similar to the way that gravity works with the sun and the planets that orbit it. So if you think of the sun as like the nucleus and the electrons are like the planets, how the sun has such a large mass that the gravity attracts the planets towards it. Think of the nucleus as being positive, those electrons are negative, and therefore they are continuously attracted to the nucleus. The Coulombic force also applies with repulsion, that particles with the same charge are going to repel each other. In the upper left-hand corner, you can see if two atoms are close to each other, the nuclei, which are both positive, would repel each other, and also the electron clouds of those two nuclei would repel each other. This is one of the reasons why it's really hard to just push two atoms super close to each other and actually get them to come together, because the first you would need to come over the repulsion between the electron clouds and then eventually the nuclei. We can quantify that. So Coulombs law and the Coulombic force or the electrostatic force just talks about that this force exists. Opposites attract like charges repel. The next slide talks a little bit more about quantifying that. And that's what Coulombs law is. Coulombs law is the mathematical formula, and you can see the mathematical formula is written over here. That the electrostatic force, think of that like E sub E, is being describing capital F, the force. So the electrostatic force is equal to, the K just is a constant, which is we're going to translate as proportional to, and then it's Q1 times Q2 divided by R squared. So what is Q1 and Q2? Well, those are the size of the charges. So if we're talking about two electrons, they would be both negative. Or if we're talking about an electron and a proton, it'd be +1, -1. But if we're talking about two protons and one electron, it'd be +2 and -1. So the size of the charges, and then R squared, you could see here, R stands for radius, or the distance between them. So what is Coulomb's law? We're going to write this down in 1 second, but it is the electrostatic force is proportional to the size of the charges and is inversely proportional to the square of the distance between those two particles. we're not going to need to use Coulombs law quantitatively, meaning I'm not going to ask you to do a calculation. There's all sorts of questions about, well, what units would you use? And so we're not actually going to have you calculate this. But what I may ask you is, which two would you see a greater attractive force? If I have 2 protons and 2 electrons, or 1 proton and 1 electron. And of course you would say, well, there's a greater attraction between the 2 protons and 2 electrons. Or what if I said between, think of the right-hand side over here. Which one is there a greater attraction? Between the proton and the electron that are close to each other, or the proton and the electron that are far away from each other? And of course the attraction would be more the closer they are together. Very similar to what you would expect to see with magnets. So Coulombs law, you can just refer back to how you would think of 2 magnets behaving. That if you have the north end of magnets, you can't push them close to each other because opposites attract and like charges repel. But as you bring 2 magnets together, you can feel the attraction get larger and larger and larger. Right? And a large or a much stronger magnet is going to be more attractive than a weaker magnet. So this is Coulombs law, and it applies to the electrons in the outside being attracted to the protons in the nucleus. It also has to do with the electrons themselves repelling each other, and in a similar way, the protons in the nucleus repelling each other. And that brings up a really interesting conundrum, because if we know like charges repel, then why does the nucleus stay together? Because the nucleus is super dense and it's packed with all protons and neutrons. And of course, neutrons are neutral. So there must be something that is holding the nucleus together. And there are really only 4 fundamental forces in science, and this is one of them. The electrostatic force is one, and gravity is another one. Strong nuclear force and the weak nuclear force are the other 2, and they only happen inside the nucleus. The strong nuclear force is what holds a nucleus together. You can see from the diagram here, the electric repulsion of protons strains the nucleus. If the only force that was going on was that electrostatic force, a nucleus would not exist. Those protons would repel each other, and a nucleus would fly, and the nucleus would fly apart. It wouldn't be able to stay together. But because we have this strong nuclear force, the strong nuclear force holds the nucleus together. It works only over very short distances, like around the size of a neutron or a proton, and it is independent of the charge of the particle. So it will hold 2 neutrons together, it will hold 2 protons together, it will hold a neutron and a proton together. It does not matter what the charge is. The fact that it only works over a small distance is why when you get larger and larger and larger nuclei, the electrostatic repulsion will take over. So a very large nucleus. So in something like uranium or plutonium or any of the other, we would say transuranium elements that come after uranium, those nuclei are so big that it's unstable, that the strong nuclear force isn't strong enough to hold it together, and you can have that nucleus break in 2. That's what's called nuclear fission. That is what goes on in nuclear power plants. It's what happened in the first nuclear bombs. So let's write down a definition for that strong nuclear force. So it is the force that holds protons and neutrons together in the nucleus, and it only holds those particles together over small distances or short distances. So inside an atom, there's really 2 major forces at play. That electrostatic force is keeping the electrons orbiting around the nucleus, because electrons are negative, the nucleus is positive. And the strong nuclear force is what's holding the nucleus together. If it was not for the strong nuclear force, the electrostatic repulsion between the positively charged protons would force the nucleus completely apart.